So let us start our discussion. So today we are going to start with our supervised machine learning topics. As part of our supervised machine learning concepts, we will be discussing our decision tree. And under decision tree concept, we will be discussing two types of decision tree. One is C 5.0, another is CART decision tree. So first we are going to discuss what is decision tree. We'll try to understand the concept. What is decision tree? And then we are going to see some examples. After that, we are going to study what is the concept of root node. We are going to discuss that. And then we are slowly going to proceed with our different types of decision trees. C 5.0 and CART decision tree for us. That is what will be the agenda today. So now let us start with a decision tree concept. So this is a tree, what we are all familiar with. This is how a tree is going to look like. We have our roots at the bottom. These are our branches. And these are our leaves. So we have our leaves, we have our branches, we have our roots. So this is how a tree is going to look like. These are the major parts of your tree. Now, suppose if I turn this tree upside down, if I invert this tree, what is going to happen? My roots are going to be on top. My roots, they are going to be on top, and my leaves are going to be at the bottom. So my roots are going to be on top, and my leaves are going to be at the bottom for us. Now, for example, you have 4 job offers, J1, J2, J3, J4. So we have to decide now which job offer we are going to accept using this decision tree. So we have to decide what job offer are we going to accept with the help of a decision tree. So what is the first condition? The salary for my job should be at least $50,000. So this is the first condition. If my salary is less than $50,000, then I'm not going to accept that offer. I'm going to reject that offer. I'm going to reject. So first job offer I have rejected. Next. I have 3 job offers left. J1, J2, J3. I have 3 job offers left. What is the next criteria? Commute time. If my travel time is more than 1 hour, then I'm going to reject that offer. I don't want the travel time to be more than 1 hour. So one of your jobs is having a travel time of more than 1 hour. So reject that job offer. Then you have 2 job offers left, J1 and J2. What is your next condition? If that company is offering you free coffee or free food, then you are going to accept the job offer. So if that company is offering you free food or free coffee, you are going to accept that offer. So one company is not offering you free food or free coffee. So you are finally going to accept the job offer, which is satisfying all the 3 conditions. Salary is at least $50,000 for us. Commute time is not more than 1 hour. And the company is offering free coffee for us. So on the basis of these 3 conditions, you have decided to offer one job. You have decided to accept one job offer. So that is what you're doing. Using the decision tree to take some decisions to solve your business problems. So now what we have to understand here? We have to understand that salary is my root node. So salary is my most important criteria in my decision tree. So therefore, I'm going to call it as root node. Then I can call my commute time and free coffee. I can call these features as my branch nodes. I can call them as branch nodes. And whether I'm going to accept the offer or not going to accept the offer, I'm going to call them as my leaf nodes. So these are the 3 parts of your decision tree: root node, you have your branch nodes, and we have your leaf nodes. So in this manner, our job is to construct this kind of decision tree. And then using this decision tree, we should be in a position to take some business decisions. We should be in a position to take some business decisions for us. That is the idea. Now, what is happening in our decision tree concept? So decision trees are being built using a concept called as recursive partitioning. So we are using the concept of continuous partitioning and then we are splitting our features. So what is the most important feature? This is salary. So salary is less than $50,000. So we are not going to accept the job offer. Then check for commute time. If commute time is more than 1 hour, you are not going to accept the offer. Then check for whether the company. So this is your decision tree, what you are constructing. And now you are recursively partitioning your data. You are continuously splitting your data into subsets. You're splitting your data into smaller subsets. This is what I'm doing. So we are going to continue splitting our data until we create our homogeneous subsamples. What do you mean by homogeneous subsamples? So until we create homogeneous groups. So for example, if salary is less than $50,000, I can categorically decide that I'm not going to accept the offer. So without any confusion, I can decide that I'm definitely not going to accept the offer. So this is a homogeneous partition for us. So you are going to keep splitting your data till you are able to create your sufficiently homogeneous groups. So if my commute time is more than 1 hour, then I've created my homogeneous group. I'm not going to accept that job offer. So until I create my homogeneous groups, I'm going to keep splitting my data into smaller subsets, into smaller regions. So this process I'm going to stop when I have sufficiently created my homogeneous subsets, and using which I can take my decisions, whether to accept the job offer or whether to not accept the job offer. So this procedure is called as divide and conquer. This procedure is called as divide and conquer. You're dividing your data set and then you're trying to conquer. You're trying to reach some decisions. You're trying to take some decisions. You're trying to conquer that piece of information, conquer that subregion, which is going to help you in your analysis. So this method is called as divide and conquer. So this is how we are supposed to create our decision tree concept. Now, my question to you is, we have considered salary as the most important feature. We have considered salary as the most important feature in our data set. But what if I'm living in a city like Bangalore? If I'm living in a city like Bangalore, then my commute time is going to become the most important feature. So for taking my decision, I'm going to use my commute time or travel time. So you have to understand that it is very important for us to find out what is the root node, what is the most important feature, using which we can construct our decision tree and we can take some decisions. So it need not always be salary as the most important feature. It need not be salary as the root node for your decision tree. It need not be your commute time. It can also be whether the company is offering free food or not. So based on this important criteria also, I can construct my decision tree. So what is important here to understand? We are assuming that salary is the most important feature. We are assuming that salary is the most important feature. But later on, there are some statistical methods that we can use and we can find out what is the most important feature in our data set, with the help of which you can construct your decision tree. So we are going to discuss some statistical concepts using which we can identify what is the most important feature in our data set. So this is what we are going to do. So for now, go with the assumption. Go with the assumption that salary is the most important feature. This is what we have to understand. Now, let us take another example. We have 3 independent variables and we have 1 dependent variable. So independent variables are income tax refund. This is one independent variable. We have another independent variable, marital status. This is another independent variable, taxable income. And then using these 3 features, we should be in a position to classify our observation. We should be in a position to identify whether our observation is a fraudulent person or he is not a fraudulent person. So using all our independent variables, income tax refund, marital status, and taxable income, we should be in a position to find out whether our observation is a fraudulent observation or our observation is not a fraudulent person. That is the idea. So now construct your decision tree. So how are you going to construct your decision tree? Assume some root node. Assume in this case, the most important criteria is refund, income tax refund for us. This is the most important criteria. I am assuming here. Now, if the income tax refund is no, check for marital status. If my marital status is married, then this person is not a fraudulent person for us. Then this person is not a fraudulent person for us. If my marital status is single or divorced, then check for taxable income. If my taxable income is greater than $80,000, then I can say that person is fraudulent person. If my taxable income is less than $80,000, then I can say that person is not a fraudulent person for us. That person is not a fraudulent person. So this is how you are going to take your decisions with the help of your decision tree. So assume a root node and you can simply construct your decision tree. Now, instead of considering my income tax refund as my root node, I can also consider my marital status as my root node. This could be the most important feature. So instead of marital status, I can also consider my taxable income. So multiple decision trees are possible for us to create. So you can consider, for example, your marital status. So this is my root node, marital status. This is my root node that I have. Now, if my marital status is married, then I'm not a fraudulent person. If my marital status is single or divorced, then check for the refund status. If my refund status is yes, then I'm not a fraudulent person. If my refund status is no, check for my taxable income. If my taxable income is greater than $80,000, then I'm a fraudulent person. This is what I can understand. I'm a fraudulent person. If my taxable income is less than $80,000, then I'm not a fraudulent person. This is what I can do. So this is how I'm supposed to classify my observations based on my different features. So here, what is my root node? My root node is marital status. Root node, you can also call it as your most important feature in your data set. In my data set, this is my root node. Now, clearly you can see that there could be more than one tree which is going to fit our same data. Now, how are we going to identify which of these decision trees are going to give us the best result? How can we find out which of these decision trees are going to give us the best result? So, experiment with these decision trees. So try out different decision trees, decision tree 1, decision tree 2, decision tree 3 with different root nodes. So try out different decision trees with different root nodes on your model. So what you are going to do? You are going to partition your data into training and testing. And then you are going to build your model on your training data set. You are going to develop your model on your training data set. And once you have developed your model, you are going to apply that model on your testing data set. And then you will find out whether your model is able to correctly classify your observations. You will try to find out whether your model is in a position to correctly identify and classify your observations. So whichever decision tree is able to correctly identify all your observations, you can call that as the best decision tree. You can call that as the best decision tree for us. So instead of experimenting with multiple decision trees like this, can I use some statistical methods and find out what is the root node for my decision tree? What is the most important feature which can help us construct the decision tree and classify our observations? If you want to find out what is the most optimal decision tree, is there any statistical method I can use? That is what we are going to find out in few minutes. So instead of experimenting with multiple decision trees, instead of trying out with different root nodes, is there any alternate option which is available for us, which can help us find out what is the most optimal decision tree? So that is what we are going to see in few minutes. Now, for example, you have discovered that out of 3 different decision trees, the best decision tree is having the income tax refund as our root node. Out of the 3 different decision trees, we have discovered that our decision tree, which is having income tax refund status as the best decision tree model, what we have developed. So this is the decision tree, what you are going to use to classify your observations. So this is the decision tree, what we are going to use to classify our observations. So for example, if somebody has given you this observation, you have to find out whether that person is a fraudulent person or not. So how are you going to do this? Simply take the help of our decision tree. So take the help of our decision tree. So study what is our observation first. Income tax refund status is no. Is not getting any income tax refund for this person. Marital status is married. Taxable income is $80,000. Now find out whether this person is a fraudulent person or is not a fraudulent person. So follow this decision tree. So what is the first thing? Check for income tax refund. What is the value? It is no. So income tax refund value is no. So come down in this direction. Then check for marital status. What is the marital status? That person is married. That person is married. Then, if that person is married, then what is your answer? The answer is that person is not a fraudulent person for us. Not a fraudulent person. So fill in the answer here as no. He is not a fraudulent person for us. That is what you have to understand. He is not a fraudulent person. Now, this is the answer. He is not a fraudulent person for us. But if I give you another observation, what is that observation is? If income tax refund is no, if that person is single, if my taxable income is $90,000, then find out whether that person is fraudulent or not. So income tax refund is no. Marital status, he is married or he is single, sorry. You have to move in this direction. And now taxable income, it is greater than $80,000. So what is your conclusion? Your conclusion is going to be that person is a fraudulent person. So you have to follow the decision tree. So income tax refund is no. That person is single and taxable income is more than 90,000 or more than $80,000. Therefore, that person is going to be called as a fraudulent person for us. So this is how, using your decision tree, you are going to classify your observations. This is what you are going to do. Using our decision tree, we are classifying our observations. So this is how you can apply your model, whatever you have developed, to your testing data. So this is what you are going to do. Now, fundamental question is, what is the fundamental question? We have assumed our root node as income tax refund. This is what we have assumed, the most important feature. But we have to statistically find out So for any given problem, you should be in a position to statistically discover what is the root node, what is the most important feature, with the help of which you can construct your decision tree and you can make your predictions, make your classifications. That is the fundamental question what we have to answer. How can we find out our root node? How can we find it? So to answer this question, we have to proceed forward and we have to start our discussion on the first decision tree model, which is called as C5.0. This is one variant of your decision tree, C5.0 algorithm. So the C5.0 algorithm is predominantly used for classification problems. So for solving classification problems, you can take the help of this decision tree C5.0. So what is the question we have to answer? How do we identify our root node? This is the question. How do we find out what is the most important feature? So that is the question what we would like to answer. How do you find out what is the most important feature? So let us see how your C5.0 algorithm is going to find out what is the most important feature. How is it going to do this? So the first question is which feature to select? What is the most important feature for constructing our decision tree? So various measures are available for us for finding out what is the best candidate, best feature. But C5.0 uses a concept called as entropy. So what is the concept? What is the statistical concept we are going to use to find out what is the most important feature or what is the root node? You are going to use the concept of entropy. So where have you heard the concept of entropy? In your second law of thermodynamics, you would have heard the concept of entropy. So what is entropy here? Entropy means it is the measure of randomness. It is the measure of randomness. It is the measure of disorder. It is the measure of disorder, measure of randomness, measure of chaos. It is a measure of disorder. It is a measure of chaos. It is a measure of impurity. All these terms you can use. Now, our job, we have to find out what is that feature which can reduce our entropy by maximum extent. What is that? We have to find out what is that variable, what is that feature which can reduce our entropy by maximum extent. So whichever feature can reduce or is capable of reducing my entropy by maximum extent, I'm going to call that feature as the most important feature. That feature is going to become my root node. So write down all these points. That feature which can reduce our maximum entropy or I should correctly say, that feature which is going to reduce the entropy by maximum extent. You are going to call that as your root node, or you're going to call that as your most important attribute or feature in your data set. So keep this definition at the back of your mind, and then we are going to further discuss our concept of entropy in few minutes. Keep that concept at the back of our mind. Now, in general, how do we identify good features? In general, how do we identify good features? Suppose if I give you these three features, three independent variables I have: ball size, ball color, ball price. Now, which among these three features are important for us to find out whether the ball is suitable for play or not? Which among these three features can give us the information about whether the ball is useful for play or not? So that is the question. So let us determine whether the given ball is useful for play or not. So which among the columns can you consider as the most helpful column? Which among the columns can you consider as the most important column for us, which is going to give us the information whether the ball is going to be useful for play or not? So first, let us try to look at our column ball color. Let us try to understand ball color. What is the information that you have in this column for ball color? The information that we have in ball color column is red. Apart from that, we don't have any other information. So what can you say? Clearly, this column is having variance is equal to 0. What do you mean by variance? Variety of information. Do I have any variety of information here? There is no variety of information. All the values are red. So even if I tell you the ball color is red, you will not be in a position to decide whether the ball is useful for play or not. So therefore, it is not helpful for us. It is not useful for us. So ball color is definitely not useful for us. It is not useful column for us because the variance is 0. So variance is nothing but variety of information, or you can call it as information in simple terms. This is what you are going to say. Information in simple terms. Now, what about ball size and ball price? Which among these two columns is having more variance? Which among these two columns is having more variance for us? Ball price, if you see, it has three different values: 1, 5, and 10. Ball size, if you see, it has 5 different values: 1, 10, 50, 100, and 1000. So which column is having more variance, more variety? Clearly, ball size is having more variety of information. More variety of information is present in our ball size column. So what is that you can do? Now, between ball price and ball size, because ball size column is having more variety of information. Therefore, ball size will comfortably help us in deciding whether the ball is going to be useful for play or not. So it is in a comfortable position to help us identify whether the ball is useful for play or not. You can do this. So among all the three columns, we have discovered that ball size is the most important column, most helpful column. But we have not used any of the concepts here. It is simple logical sense with the help of which you are able to decide that ball size is going to be the most important column in our data set. But we are supposed to use our concepts, right? We are supposed to use our entropy. We're supposed to use our information gain. All these concepts are yet to be discussed first. So now the question is, can you identify in the same manner by using the concept of entropy? Can you do that? Can you quantify the usefulness of your columns? What is the question? Can we quantify the usefulness of your columns or features? Can we find out what is the most important feature using the concept of entropy? Can we do that? Is the question. What we would like to answer. So before we try to answer this question, let us try to study some properties of entropy. So first we are going to look at some properties of entropy. And then we are going to discuss one small formula for how to calculate mathematically your entropy. So what are the properties of entropy that you have? Typically, entropy is measured in bits. So bits is the unit of measurement for us. This is the unit of measurement, bits. If there are two possible classes, if you are working with two class problem, yes or no, birth and death. If it is a two class problem, then what can you say? The entropy is going to lie in the range of 0 to 1. So if it is a two class problem, your entropy is going to lie in the range of 0 to 1. So entropy is equal to 0. That means there is no disorder, no chaos in the system. Entropy is equal to 1. That means there is maximum disorder, maximum chaos in the system. So for n classes, how can you generalize? Entropy ranges between. Entropy ranges between 0 to log n to the base 2. This is the formula. Entropy for n classes, it ranges between 0 to log n to the base 2. So n is number of classes for us. So if your value of n is equal to 2, then entropy value is going to lie in the range of 0 to log 2 to the base 2. What is log 2 to the base 2? It is 1. So entropy value is going to lie in the range of 0 to 1 for us. Entropy is going to lie in this range, 0 to 1 for us. So write down all these formulas so that you remember in your notes. So minimum value for your entropy is going to indicate that sample is completely homogeneous. So minimum value for entropy is going to indicate your sample is homogeneous. While the maximum value is going to indicate that data is as diverse as possible. There is maximum disorder in the system. Maximum impurity is there in the system for us. This is what you can understand. And no group has even small majority. So there is no group which is having a small majority. The entire group, you can call it as not homogeneous for us if the entropy value is very high. Now, how can you mathematically compute your entropy? How can you find out mathematically what is the entropy for a group? What is the formula? Sigma I is equal to 1 to n minus p of I into log p of I to the base 2. What is the entropy formula? It is sigma I is equal to 1 to n minus p of I into log p of I to the base 2. That is the formula what you are going to use. So mathematically, you can compute using this formula. What is the entropy of your subsets? What is the entropy of your groups? You can do that. So diagrammatically, how can you represent your entropy? It is going to look like this for a two-class problem. So 0 to 1. And these are your two classes. Birth is one class and death is another class. So what is the entropy at birth? There is no confusion for us. Entropy value is 0. What is the time of, at the time of death, what is the entropy value? It is 0. There is no confusion. So where is the confusion right now? Now. This is where you have maximum confusion. So entropy value is going to be 1 for us. So this is how you can diagrammatically represent our entropy concept for a two-class problem. It is going to lie in the range of 0 to 1. Now, there is another concept what we have to understand. It is called as information gain. What is information gain is? It is equal to entropy before split minus entropy after split for us. Entropy before split minus entropy after split. What is the meaning? Suppose you have this region or you have this group here. Find out entropy for this group. Some value you are going to get. Now split this. Split this group into smaller subsets. Find out what is the entropy at this node. Find out what is the entropy at this node. So entropy before split, you had some value here. Now you are splitting this node into two smaller nodes for us. Find out what is the entropy here. Find out what is the entropy here. Then what you are going to do? Take the summation of both these entropies and you are going to call this as entropy after split. You are going to call that as entropy after split first. So what is your purpose now? What is that you're going to do? You are going to subtract entropy before split minus entropy after split. This is what you're going to do. This is what we are going to do. Now, whichever feature can reduce your entropy by maximum extent. That means whichever attribute is capable of reducing your entropy by maximum extent, that feature you are going to call it as root node for us. In other terms, simply you can say whichever feature is going to have the highest information gain. What is that statement I just made? Whichever feature is having the highest information gain, you are going to call that feature as our root node. So now, what is our job? Our job is to find out what is the information gain for each and every feature, for ball size, for ball price, for ball color. And whichever feature is going to give you the highest information gain value, Whichever feature is capable of reducing the entropy by maximum extent, that feature you are going to call it as our root node for us. So whichever feature is going to have the maximum information gain, you are going to call it as our root node, our most important attribute for us. Most important attribute. So remember all these points, whatever we have discussed so far. Right from entropy. So all these properties of entropy are important for us. Entropy is measured in bits. This is the unit of measurement. Entropy can have two classes. If entropy is having two classes, then the range of entropy is going to be from 0 to 1. For n class problem, entropy is going to lie in the range of 0 to log n to the base 2. And minimum value for entropy is going to indicate that sample is completely homogeneous for us, while the maximum value is indicating that the data is as diverse as possible. Data is as heterogeneous as possible. What is the opposite of homogeneous? It is called as heterogeneous. And this is the formula to find out your entropy. Now, what is the next course of action? You have to apply this formula. How can we apply this formula? On the same data set. And find out our entropy for our different features. Can we do that? Yes, we can do that. So we can apply our formula I is equal to 1 to n and minus p of I log p of I to the base 2. We can apply this formula. Find out entropy before split. Find out entropy after split. And then take the difference. Find out what is the information gain. Whichever feature is going to have the highest information gain, you're going to call that feature as root node. Or you're going to call that feature as most important attribute. This is what you're going to do. So we're going to do that after a break. So take a break here for 10 minutes, and then we are going to come back and we are going to calculate our entropy and information gain. And then we'll discuss more examples. So take a break and come back after 10 minutes. So let us start our discussion. So we have our Excel file here. Let's try to understand the concept. Now, we're going to use our formula. What is that formula that we have seen? Sigma I is equal to 1 to n minus P of I log P of I to the base 2. This is the formula what we are using to find out our entropy concept. Now, first find out what is the entropy for the system. What is entropy for the system? First find out that. So how many observations you have? Totally 5 observations you have. Out of these 5 observations, how many observations are belonging to yes category? 3. How many observations are belonging to no category? You have 2. So what you are going to do? Apply this formula. Minus 3 by 5 into log 3 by 5 to the base 2. So 3 out of 5 are your observations belonging to yes category. Minus 2 by 5 into log 2 by 5 to the base 2. So calculate this. When you calculate this, you are going to get a value of 0.97. This is the total entropy. Entropy before split. You are not splitting your data. Entropy before split is equal to 0.97 for us. Now, what is entropy after split? Split your data. So split our data. So what is the split I'm going to do? I'm splitting my first root node ball size and I'm splitting it like this. This is a split what I'm doing. So ball size. If my ball size is greater than 50, then my ball is not useful for play. If my ball size is less than 50 or less than or equal to 50, then my ball is useful for play. So this is the information what I have. If my ball size is greater than 50, then my ball is not useful for play. If my ball size is less than or equal to 50, then it is useful for play. So find out what is the entropy after split. What is the entropy here on the left hand side? We can clearly say on the left hand side because it is a homogeneous group for us. What is that you can say? You can say that entropy is going to be 0. What is the entropy on the right hand side? Because again it is a homogeneous group for us. So what is the answer you can tell me? This is also going to be 0. Manually also we can calculate. Minus 3 by 3 for the left hand side if you want to calculate. Minus 3 by 3 into log 3 by 3 to the base 2 minus 0. So log 1 value is 0, 0 minus 0 is 0. So entropy for left hand side is 0 for us. Entropy for the right hand side, minus 2 by 2 into log 2 by 2 to the base 2 minus 0. We don't have any yes observations. So this is also 0. So total entropy after split is 0 for us. So what is happening? You are able to reduce your entropy from 0.97, which is before split, to entropy value of 0. You are able to completely eliminate the entropy, eliminate the confusion when you are considering the split. Ball size greater than 50 or less than or equal to 50. So like this, you are supposed to solve for it. Now, what is the information gain for your ball size? 0.97 minus 0. So like this, you have to experiment with different features and different split points. You have to experiment with different split points. And then whichever feature is going to give you highest information gain, whichever feature is going to reduce your entropy by maximum extent, that feature you are going to call it as your root node. So this is the manual calculation what you're doing. Finding out your entropy and finding out your information gain. So no need of doing any manual calculations in Python. All this is only for your explanation. To understand the concept, we have manually performed some calculations. But in Python, it is very straightforward. Simply say criteria is equal to entropy. When you mention your criteria in the background, it is going to use your C 5.0 algorithm. And it is going to find out what is the root node. All these calculations, all this heavy lifting will be done by the simple condition criteria is equal to entropy for us. So that is what we are going to see in our Python programming. Simply say criteria is equal to entropy for us. Now, let us proceed. So we have another example here. Predict whether a potential movie would fall into three categories: critical success, mainstream hit, and box office bust. So we have to predict whether a potential movie is going to fall into these three categories or not. So how many features you have? You have two features. One feature is A-list celebrities. This is one feature that you have. Next, you have another feature called estimated budget. This is another feature you have. So what is happening? If you look at your data, let us say you have around 30 observations. Now, based on your features, you are able to explore your data. So this is how my data is distributed. Now, if you want to apply the concept of your decision tree, what is that you are going to do? What is the first step? If you want to decide, if you want to classify your observations using our two features, whether they are going to be called as critical success movies, whether they are going to be called as mainstream hits or box office bust, what is that you are going to do? Split your data. So the starting point is always splitting our data. So imagine that the most important feature or root node in our data set is A-list celebrities. So this is the most important feature in our data set. So we are doing our first split like this. This is our first split. A-list celebrities. Now, when you split your data like this, what is the information that you are getting? You are able to divide your data into two regions, region 1 and region 2. What can you say about region 1? Region 1 observations are having very less number of A-list celebrities. They are not having any star power. And also, their budgets are ranging from small to high. So what can we say? If your movie budget is ranging from small to high, and if there is no star power in the movie, then your movie is going to become a box office bust. Your movie is going to become a flop movie for us based on very less number of celebrities, and if your budgets are ranging from small to high. So this is how you can classify your observation into one of the categories. What about region 2? Region 2 It is not a homogeneous group for us. So you have to keep splitting your data till you create your homogeneous partitions. So again, you are going to partition your region. So again, partition our region. So this is the second split what I'm doing with respect to my second feature. What is my second feature? It is estimated budget. Now what can you say? Now I have created this homogeneous region for us. I have also created this homogeneous region for us. Now, if my estimated budget is high, if my budget for the movie is high, and also my number of A-list celebrities in that movie is high, what is that I can say? My movie is going to become a mainstream hit. It is going to become a commercial success. It is going to become a mainstream hit for us. This is what we can say. If your budget is high, and also if number of A-list celebrities are also high, the movie is going to become a mainstream hit for us. What is the next thing you can say? If number of A-list celebrities are high, and also if your budget is ranging from small to medium, then what can you say about the movie? The movie is going to become critical success movie. So the movie is going to get critical acclaim. That is what you can see from this data. So you are able to partition your data using our features, and you are able to segregate your observations into homogeneous groups. That is the idea of decision tree. That is the concept what you're applying here. So same decision tree logic we are able to apply. So the group at the left-hand side corner of your diagram is composed entirely of critical acclaimed films. All these are your critical acclaimed films. This group is distinguished by high number of celebrities and also relatively low budget. At the top right-hand side corner, majority of the movies are box office hits with high budgets and also large number of celebrities. So high budgets and large number of celebrities. Your definitely movie is going to become commercial success. Mainstream hit it is going to become. Then the final group. If your movie is having very little star power and the budgets are ranging from small to large, then movie is going to become a box office bust. Or you can say the movie is going to become a flop movie for us. You can say that movie is going to become a flop movie for us. So how can you represent this analysis what we have done in a decision tree? So this is how we can represent. You are working with 30 observations. And now first check for your number of celebrities. This is our root node. Now if number of celebrities are low, then what will happen? The movie is going to become a box office bust. Movie is going to become a flop movie for us. If number of celebrities are high, then what is going to happen? We cannot decide. Then check for the next condition. Split your next feature budget. Split it using your budget. So if your budget is high, then the movie is going to become a commercial success. Mainstream hit. If the budget is low, then the movie is going to become a critical success. So this is the method in which you can use the concept of decision tree and you can take some decisions. You can solve your classification problems. That is how you are going to do. Now, let us proceed. What is the next concept? Pruning. What is the meaning of pruning? Pruning in English language means cutting down or trimming. Or trimming, you can say. So my question to you is, if I allow my decision tree to grow indefinitely like this, what is going to happen? If I allow my decision tree to grow like this, then the branches for my decision tree are going to become weak. So if my tree grows overly large, my tree is going very, very large, then what is going to happen? The decisions, what my tree is going to take, it is going to become overly specific for us. The decisions, what my tree is going to take, they are going to become specific. They are going to become very customized. So therefore, these kind of models are not suitable. Why? Because they are going to give you very specific results. Or you can call these models as overfitting models. What do you mean by overfitting model? Your model is overlearning from your data set. Overfitting means your model is overlearning from your data set. Your model will tend to by heart the observations which are present in your data set. It is going to learn the values which are present in your data set. What is going to happen? It is memorizing your data set. So whenever your model is memorizing your data set, if I change my data set, what is going to happen? The model will not be in a position to perform on this new data set. So such models are called as overfitting models or overlearning models or memorizing models. So therefore, what is it you have to do? You have to cut your branches. We don't want to allow the tree to grow indefinitely. So cut your branches. So when you cut your branches, you are going to prevent this problem of overfitting. Your models are not going to overfit on your data set. Your models are not going to memorize. Your models are not going to overlearn from your data set. So this pruning is done to prevent your model from overfitting. So when you are not having the problem of overfitting, then whatever data set you are going to do, your model will be able to perform well. It will not have any problems. So model will be able to perform well on unseen data. So model will be able to produce generic results on unseen data for us. That is the advantage when you apply this pruning concept on your decision tree. So pruning nothing but you are controlling the size of your decision tree. And you can prevent the problem of overfitting. That is the concept. So write down in your notes. To prevent the problem of overfitting, you can apply the concept of pruning. So it is that time of the day. It is 7:30 for us. So now it is time for you to fill in your attendance sheet. It is available in your Zoom chat window. So try to fill in your details without any mistakes. And then you can come back and we can continue our discussion. So first priority, try to fill in your attendance sheet and then come back and listen to our lectures. So this is the concept of pruning we are going to apply to control the size of your decision tree, to control the depth of your decision tree, you can use. Now, what is the next decision tree concept that we are going to study? It is called as CART algorithm. What is CART? CART is known as classification and regression. So CART algorithm can be used for both our classification problems and also our regression problem. So previously, C 5.0 algorithm was only used for classification, but now you can use it both for classification and also regression. So let us see how this model is going to work. Let us see how this model is going to work. So first we are going to discuss the example of classification problem. So classification, when you want to perform using your CART algorithm, what is the first thing that you have to do? Like always, the first thing what we have to do is we have to identify what is the most important attribute. We have to find out what is our root node for our decision. So how are you going to find out our root node? When you are working with CART algorithm, what is that you are going to do? You are going to apply the concept of Gini impurity. So what is this concept of Gini impurity? It is very similar to our entropy concept. Very, very similar. So what is the logic? Whichever feature is capable of reducing my Gini impurity by maximum extent, I am going to call this as my most important feature. This is going to become my most important attribute in my data set. It is going to become my root node. So whichever feature is going to reduce our Gini impurity by maximum extent is going to become our root node. So how are you going to calculate your Gini impurity? What is the formula? 1 minus sigma I is equal to 1 to n pi square. So for example, let us consider one small group and find out what is the Gini impurity for that. So this is my group. Find out what is the Gini impurity. So how are you going to find out? 1 minus, what is the proportion of yes in this group? 2 by 6 whole square. Plus what is the proportion of no? 4 by 6 whole square. So what is the Gini impurity now? 1 minus 5 by 9, which is equal to 0.44. So this is how you are going to find out the Gini impurity for my group or for my node. Now, whichever feature is going to reduce this value by greatest extent, by maximum extent, then that feature I'm going to call it as a root node for us. So whichever feature is going to reduce my Gini impurity by maximum extent, that feature I'm going to call it as my root node. So same logic, whatever we have used there in C 5.0, we are using the same concept here also. So decision tree is going to search through all the features for the value to split, and it uses the criteria of greatest reduction in Gini impurity. So whichever feature is going to help us in the greatest reduction of Gini impurity, that feature is going to be selected as our root node or most important feature. So how are you going to program this logic in Python? How are you going to do that? No need of any manual calculations first. So what is that you are going to do? Simply you can say criteria is equal to Guinea. Simply say this. Criteria is equal to Guinea. If you say in the background, it is going to apply here in Guinea impurity concept. In the background, it is going to apply your Guinea impurity concept. And then it is going to find out what is the most important feature. Find out the root node for our data. So if you want to apply your C 5.0, you can say criteria is equal to entropy. If you want to use your CART algorithm, you can say criteria is equal to Guinea. So very simple, very straightforward applications are. That is the logic. Now, what if I want to apply my decision tree model to solve my regression problems? Can I do that? Answer is yes. You can solve your regression related problems also using your decision tree model. You can do that. So how are you going to do? That is the question. So for finding out our root node, when we are applying our CART decision tree model to solve regression problems, we have to work with one condition. What is that condition? We are going to use the concept of residual sum of squares. Wherever you heard this term residual sum of squares or error sum of squares, when you were discussing the concept of linear regression, there you would have applied the concept, a residual sum of squares. So there you would have studied. So what is our objective now? If we want to find out the best feature, or if we want to find out what is our root node, then what is the condition that we are going to use? What is the criteria that we are going to use? Whichever root node is going to minimize our residual sum of squares. So whichever feature is going to reduce or minimize our residual sum of squares, that feature is going to be considered as root node first. So first let us try to understand what is residual. What is error? What is the formula for error? Actual minus predicted value. This is the formula for error. Y minus y hat. Now take the square of your error and then take the summation of your error. You are going to get your error sum of squares or residual sum of squares. This is the mathematical expression which can be used to represent your residual sum of squares for your data. So we are going to use this. Whichever feature is going to reduce this, minimize this by maximum extent, that feature is going to be our root node. That is the concept. So what is the example that you are going to take? Let us consider one example. So let us try to understand the example with simple data set having two variables. So what are these variables that you have? You have our price in dollars and you have your review score rate. So price is our independent variable and we should predict our review score rate. Now, what is the first thing that you're going to do whenever you get your data in this manner? Try to sort your data in the ascending order of your dependent variable. Try to sort your data in the ascending order of your target variable or dependent variable, which is review score rating here. So data is sorted. Okay. After sorting your data, then try to visualize your data. Try to visualize our data using scatter plots. Try to do that. So this is how our data is looking like. This is the data. You can call this visualization as review score rating versus price. Now, what is the first thing you have to do always? Split your data. That is the fundamental thing. Whenever any problem is given to you on decision tree, simply split it. So we are going to split it like this. So split your data. Split our data like this. So this is one region for us, region 1, and this is region 2 for us. So you have region 1 and region 2. So these are two regions. Now, what is it you are going to do? So write down price less than 11. You have partitioned this data into region 1 and region 2 first. What is the average review score rating for region 1? What is 10 by 1? 10. This is the average review score rating. What is the average review score rating for region 2? Add all your observations and divide by n, total number of observations that you have in region 2. So do that first. So you have split your data using price less than 11 as the root node, and then you have partitioned your data into two regions, region 1 and region 2. So this is my region 1, this is region 2. So in region 1, I just have one observation. What is the average? 10. Region 2 has so many observations. Find out what is the average, 58.9. Now, once you have done this, this is the first step what you are going to do to identify your root node for your decision tree regressor problems. That is what you are doing. Next, what you are going to do, find out your residual sum of squares. So what is that you are going to do? Find out your residual sum of squares. So residual sum of squares is nothing but the square of the difference between your actual value and your average value in each region. So for region 1, what is the actual value? 10. What is the average value? 10. 10 minus 10 whole square plus. Region 2. What is the first actual value in region 2? 10. What is the average value? 58.9. So like this, you are going to consider all your observations in region 2. Take the square of their difference and then add. All the square differences you are going to add. And this will be equal to our total residual sum of squares. So what is the total value that you are getting? 21139.8. So 21,000 is the value of our residual sum of squares. So you can visualize it like this. So for price at 10, what is your residual sum of squares? It is 21,000. So now what you are going to do, you have to repeat this process until you find that threshold value, or until you find that cutoff value which can minimize your residual sum of squares by maximum extent. So you have to keep repeating this process until you are able to reach that minimum residual sum of squares. So what is it you are going to do? Select our next split point. What is our next split point going to be? Partition our data like this. Now this is region 1 for us. This is region 2. So price less than 12. This is our root node. Now I have my region 1, I have my region 2. So this is my average review score rating. So what is my average review score rating? 10 plus 10 by 2. This is 10. Find out what is the average review score rating for region 2. Find out that. So this is my average review score rating for region 2. So again, repeat this process. Find out your residual sum of scores. So find out your residual residual sum of squares. Again, it is the same thing. 10 minus 10 whole square plus 10 minus 10 whole square plus this thing is going to change because the average has changed for us. So 61.8 whole square. So add everything, add the square differences of your residuals, and then what is the residual sum of square value you are getting? 18,000 now. So what is that you have done? You are able to minimize your residual sum of squares from 21,000 to 18,000 for us. So which is a better root node now? Price less than 12 is a better root compared to price less than 11. That is the idea. So again, proceed. Continue to proceed in the same direction. So we are going in the right direction. So then again, partition your data. At price less than 13 first. So go back and split your data. Price less than, not here, but here. So point by point we are going. So price less than 30. Now you have your region 1 and you have your region 2. So find out what is the average. For region 1, 10 plus 10 plus 10 by 3, 10. 10 is the average. Find out what is the average for region 2. Add all your observations, divide by total number of observations. That is what you're doing. So do the same thing now. So price less than 30. So average for region 1 is 10 and average for region 2 is 65 for us. Then find out what is the residual sum of squares. Same thing. Same thing, let us repeat. Residual sum of squares. So what is your residual sum of squares? Now 10 minus 10 whole square plus 10 minus 10 whole square plus 10 minus 10 whole square. So region 1 is covered. Now region 2. This will change to 65. So what is your residual sum of squares now? 15,762. So again you are able to reduce. Yeah. Residual sum of squares. Now which is a better root node for us? Price less than 30. This is a better root. So like this, keep doing, keep continuing the process. And then the process is going to continue until the calculation of residual sum of squares till the last data point. Now at this point, at price less than 19, what is that we are getting? We are getting our region 1 and region 2. So what is the review score rating in region 1? 25.9. What is the review score rating in region 2? 91. So at this cutoff point, you are able to get the least error, least residual sum of squares. So this is the root node for us, which is able to help us minimize our residual sum of squares. So price with threshold value of 19 has smallest residual sum of squares. Now what we are going to do? Now if you see, my region 1 and region 2, both of them are having still more observations. More observations are nothing but more information. More data means more information. So what you can do? You can extract this information. Let us extract. You can extract this information. How you can extract this? Split it further. What you are going to do? You are going to split your region 1 into smaller subsets. Split your region 2 into smaller subsets. So what is that you're doing? Because there are 10 data points within your region R1, you can split it further. So what is the criteria I'm going to use for splitting my region further? If I have more than or equal to 6 observations in any of the region, if I have more than or equal to 6 observations, in any of the region, what is that I'm going to do? Split it. Why 6? That may be a question. You can have 7, you can have 8, you can have 9, whatever may be the condition. The idea is to extract the remaining piece of information, which is available to us in region 1 or region 2. So this is one condition what I'm trying to establish. Instead of 6, I can take 5 or 7 or 8, whatever may be. I can take that value. So if your region 1 or region 2 is having more than or equal to 6 observations, then split it further. Then you are going to split it into smaller subsets. We can do this. But if your region is having less than 6 observations, then stop it. Then do not further split your region. If your region is having less than 6 observations, do not split it further, because it is going to overfit your data set. It is going to overlearn from your data set. Your decision tree is going to become very specific. You remember that concept we have discussed? So that is the problem what you are going to face. So you are going to continue splitting your data until each of your regions are going to have greater than or equal to 6 observations. Once you discover that any of your region is having less than 6 observations, then do not split that region. So that is the threshold or condition what we are trying to establish. So if the region is having less than 6 observations for us, then please do not split that region further. Stop it. Stop it. So now what you are going to do? You are going to further subdivide your region 1. So we are going to subdivide our region 1 into smaller subsets. So how are you going to subdivide? It is the same procedure again. So instead of focusing on the entire data set, you are only going to focus on region 1 now. So go back. Where are we? So go back to our data set. And what is that you are doing? Price less than 19. So where is price less than 19? This is the point. So this is your region 1. So don't forget about what you have here. Now only focus is to further subdivide this region. So again, start from your first index point, second index point, third index point, like this you start and find out what is the best threshold value. Find out what is the best cutoff point, which can minimize your residual sum of squares. That is what you are going to do. So same thing we are doing here. Same thing. So for region 1, you are able to find out the best cutoff value at price less than 15. So price less than 15 is giving you least residual sum of squares. That is the idea. So this is our focus point. So you have successfully subdivided our region into smaller subsets. Now repeat the same thing for region 2 also. Repeat the same thing for region 2. And you can further subdivide your region 2 also into smaller subsets. That is what you can do. So this is my region 1. I have subdivided into smaller subsets. This is my region 2. I have subdivided into smaller subsets. So this is how we are going to construct our decision tree. That is the logic. Now all this, we are doing it with only one feature, price. And we are trying to estimate our review score rate. But what if you are working with multiple features? What if you are working with multiple features? What is that you are going to do? You have to repeat this process. We have to repeat this process. And whichever variable is going to give us the least residual sum of squares, that feature is going to be considered as our root node. That feature is going to be considered as our most important attribute in our data set, and using which you can construct your decision tree. So for multiple independent variables, what is the method? A residual sum of squares will be computed for all independent variables, and whichever variable is giving the lowest residual sum of squares, it will be used as root node for us. And the process goes on, and the tree will be built using this root node. So using that root node, the tree will be constructed for us. So remember all the concepts what we have discussed today. So right from our C 5.0 algorithm to CART algorithm, what is entropy? What is information gain? What is Gini impurity? What is the mathematical formula? How to calculate your Gini impurity? Then, how can you apply your CART algorithm in classification problems? How can you apply your CART algorithm in regression problems? So all these concepts are important for us. How are you going to apply them in Python? You can simply say criteria is equal to your entropy. If you want to work out your C 5.0 algorithm, if you want to work out your CART algorithm for classification, you can use criteria is equal to Gini, and you can work out your CART model for classification. So all these things we are going to see in Python. We are going to practice those concepts. And also we are going to start with new set of topics again from tomorrow. We are going to build our logic on decision trees, and we are going to discuss all the related concepts which are closely associated with our decision tree models. That is what we are going to see. So please try to revise whatever topics that we have discussed so far. It is very important for us. And then going forward, we are going to see some more decision tree concepts like what we have discussed today. So revise all the mathematical formulas what we have seen. Sigma I is equal to 1 to n minus p of I log p of I to the base 2. All these concepts are based out of information theory for us. And then your Gini impurity formula 1 minus sigma I is equal to 1 to n pi whole square. So all these formulas try to revise, and then we are going to connect back tomorrow, and we are going to continue our discussion on our supervised machine learning topics. So till then, take care, stay safe. Thank you very much for your time, and all the best. See you tomorrow.